Broadcast is now starting. All attendees are in listen-only mode.
Good morning and welcome to the August Pacific Northwest DEWS Drought and Climate Outlook webinar. My name is Britt Parker and I'm with the National Integrated Drought Information System at NOAA. This bi-monthly webinar series hosted by Nidus, the Northwest Climate Hub, and the Oregon Climate Change Research Institute is designed to provide stakeholders and other interested parties in the Pacific Northwest with timely drought and climate information. Each webinar will be tailored to reflect current and forecasted conditions and climatic events, but will also include discussion of observed impacts and other relevant updates from across the region. Webinars and recordings and other supporting materials will be posted on Droughtgov later this week. Note, after today's webinar, you will have the opportunity to provide feedback that will help us improve this webinar series. So please take a moment to tell us what you think. Oops. So today's speakers include Nick Bond from the Office of the Washington State Climatologist, who will give us the climate recap and current conditions, Robin Fox with the National Weather Service Weather Forecast Office, Spokane, who will talk to us about the seasonal conditions and climate outlook, and Sonia Hall with Washington State University, who will be talking about FireEarth, communicating research, helping us understand what makes communities vulnerable to wildfire. I'm also joined by Megan Dalton from OCRI, who will help us with our Q&A as we proceed through the webinar. Before we begin the presentations, we wanted to highlight the partners who make this webinar series possible. The Northwest Climate Hub develops and delivers science-based, region-specific technologies and practical information that will assist agricultural and natural resource managers with climate-informed decision-making in Idaho, Washington, Oregon, and Alaska. Please visit their website listed here to get more information. The Oregon Climate Change Research Institute is a network of dozens of researchers at Oregon's public universities that work closely with other public and private entities. OCRI is housed at Oregon State University. OCRI advances understanding of regional climate impacts and adaptation and cultivates climate-informed communities. Nidus was established in 2006 by public law with a mission to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. Nidus is building the foundation of a national drought early warning system through the development of regional DEWS, where networks of partners and stakeholders share information and actions that help communities cope with drought. While the ultimate goal is a national early warning system, we recognize that impacts and early warning information differ across the region. Each DEWS has the same base ingredients, but ultimately have their own flavor to reflect the needs of their region. The Pacific Northwest DEWS was officially launched in February 2016, and our strategic plan and information on current activities is available on Droughtgov. To facilitate our early warning system, more precipitation observations are needed. We encourage you to join COCOROS, the Community Collaborative Rain, Hail, and Snow Network. This is a unique, nonprofit, community-based network of volunteers of all ages and backgrounds working together to measure and map precipitation, rain, hail, and snow, as well as condition reporting. Observations by COCOROS observers of precipitation events or the lack thereof are important to capture and improve our understanding of our weather. To become a volunteer or to learn more, visit cocoros.org or contact your local state coordinator, and I will put the names and their emails in the chat box in a moment if you're interested. I wanted to highlight a few pieces of information from around your Pacific Northwest DEWS. Nidus has launched 2 new interactive features on Droughtgov that will make it easier for decision makers and the public across the U.S. to share timely, reliable drought information. First, new customization and sharing options for all maps make it easier than ever to create custom high-quality maps to include in drought or risk mitigation plans, share on social media or in media briefings, communicate with stakeholders, or report on drought impacts across the United States. Second, interactive economic sectors maps show sector-specific information alongside key drought and climate indicators to provide vital information for public and private sector decision makers to monitor, plan for, and mitigate the impacts of drought. Please note that there are 2 open Coping with Drought grant competitions through Nidus, one focused on building tribal drought resilience and one on applied research around ecological drought. The application deadline is October 18th, and more information can be found on Droughtgov. And I'll also put this link into the chat box in a moment. Finally, we also wanted to highlight that there are now tool summaries and case studies on the Climate Toolbox. These resources will allow users to explore the tools and how various partners are using those tools in their planning activities and are available on the Toolbox. With that, I'm going to turn it over to our first presenter, Nick Bond, to talk about a climate recap and current conditions. And,
thank you.
Yep, it should be coming your way now.
Yeah, here we go. And you should see my title slide, and let's go.
Perfect.
Yeah, so I, with Karen Bobaco's help here, I'd like to just briefly go over some of what we've been seeing here in the Pacific Northwest recently. And I want to go back a little bit to earlier this year, and in particular, at the end of February, early March, when we were actually feeling pretty good about ourselves from a drought perspective. Here, this map shows for the entire US West, the snow water equivalent with triangles with the points pointing up. That's good. More than 100% for that time of year of the snow water equivalent. And just the hotter the color and the downward pointing triangles, that's bad. It was clearly really bad in the California and especially the Arizona and desert Southwest. Rockies were kind of a mixed bag, and we were actually in pretty good shape here in the Washington and Oregon Cascades and Olympic Mountains at least. But then spring came along. And in particular, I'm here actually looking at the 5-month period from March through July. It was really dry. In fact, it was that 5-month period was the record driest for much of eastern Washington, some of northern Oregon, and northern Idaho. And so, yeah, obviously some problems ensued, as most everybody knows. Looking back a little bit, well, no, it's the same period, but just I want to compare the year of 2020 with 2021. And so on the left is the temperature anomalies during 2020, March through July again. On the right is 2021. There are different scales there with the deep reds in 2021 actually showing more than 5 degrees temperature anomalies. And so just what a difference a year makes. And just when you're talking to the public, this year is not the new normal. The climate can change pretty fast, but it doesn't change obviously from year to year. Just an example of a tremendous interannual fluctuation. All right. So let's go back a little bit less in time, 3 months here. Temperatures relative to normal on a percentile basis on the left, precipitation on the right. So we're looking at May through July. Record-setting temperatures across much of the Pacific Northwest, most of Oregon, most of Idaho, some of Washington leaking into and western Montana. And so obviously that included the extreme heat wave at the end of June, this period, which lasted east of the Cascades, so persisted into July. From a precipitation point of view, there were also some places that were the record driest on record. And so clearly the last 3 months have really been extreme. This was all associated with, not surprisingly, high geopotential heights aloft. And here, and just if you, for some of us that suffered through atmospheric thermodynamics and so forth, that it the hypsometric equation for every if the sea level pressure doesn't change, for every 20 meters higher in the 500 millibar height, on average the atmosphere from the surface to 500 millibars is 1 degree C warmer. And so these positive anomalies of 50, close to 60 meters reflects over the lower troposphere temperatures that were on the order of 2.5 to 3 degrees C warmer than normal. And the sense of that flow was obviously to bring especially warm temperatures into Oregon. All right, let's look back just the last 30 days. Again, temperature on the left, precipitation on the right. Precipitation, again, is in a percentile form. The temperatures there are just excursions from normal. Warm across basically the entire Pacific Northwest. The precipitation kind of more of a mixed bag. The Northern California, Western Oregon, Western Washington, Central Washington, all dry, but there was some relief for parts of the Pacific Northwest, in particular Southern Idaho and parts of Western Montana. The bullet points at the bottom there, looking at just the last full month, July for the Northwest was 5.1 degrees above normal, which was set a record for that month by a considerable margin, beating the previous record that was 3.8 degrees above normal, with normal being for the 91 to 2020 period. And so we didn't just set a record, we thrashed it. And then again, on the dry side overall, with precipitation less than half of normal. Some of the reflection of this is in the reservoir storage. And here, the teacup diagrams from a few places in the Bureau of Reclamation sort of series of reservoirs and so forth. What I've highlighted here is the Rogue basin there at left, and the teacups there showing the reservoirs in that basin are basically empty. And some of the, you'll have to squint, but some of the stream flows there are also indicated, and very low numbers like 0 cubic feet per second. That's about as low as it can go. And a lot of single digits in, admittedly, some of those smaller streams. Also highlighting the Eastern Oregon area there, where also a lot of reservoirs essentially empty. And again, some pretty low stream flows there. One bright spot is the Yakima Basin that took advantage of that healthy snowpack in the Cascades. And so the reservoirs there are in much better shape. All right. A few more little tidbits here, and then I want to turn it over to Robin. But first of all, on the left here shows last week the total moisture in a percentile basis from the UCLA drought monitoring system. Those browns and reds show where, and at this time of year, it's basically soil moisture is really low. Not surprisingly, been so warm and dry. On the right are 28-day average stream flows for the Pacific Northwest, with greens and blues showing more healthier stream flows. And there are some streams that are that way, but a lot of browns and reds and yellows showing below normal to record low values of stream flow, again, 28-day averages. And so it's not everywhere that's in terrible shape, but a lot of the Pacific Northwest is. And that's reflected in the latest depiction from the U.S. Drought Monitor, where the that brown color there, D4 exceptional drought, is touching, all of the states in the U.S. West, and in particular my own state of Washington. This is the first time, this first summer we've had exceptional drought in since this sort of depiction has been being provided. California had, some stints with exceptional drought some years ago, but I think in terms of, and somebody feel free to correct me if I'm wrong, but in terms of the percentage of the area in the West that is afflicted with exceptional drought now, this is close to it not being a record. Now, Robin is going to tell us how our likelihood of getting out of this drought. There's, I'd like to direct your attention to, you might not be familiar with this relatively new tool that NOAA has, a drought termination and amelioration tool, which by climate division, looking at past statistics, and from the perspective of the Palmer Hydrological Drought Index, or PHDI, what are the odds of getting out of the present conditions? And so what this shows is for Eastern Washington, Eastern Oregon, Western parts of Western Montana and Southern Idaho, that our odds of ending drought are really pretty slim here by the end of the winter coming up. There's a better chance, looking at the right, that it'll be ameliorated, which means a PHDI index of -2, but to end it, to be just at -0.5, which is shown on the left, that's going to be a tall order. And that has some real consequences here for many sectors across the Pacific Northwest, and in particular, one group that's really been hit hard are the wheat farmers. Almost all of those are dry land agriculture, not benefiting from the water that's available in the Yakima basins, let's say. I'm not a farmer and I can't really interpret this photo that well, but my understanding is the wheat, even in the places that it's growing better, is shorter than usual, and certainly yields are way down. I've seen estimates that it'll be 40 to 50% losses overall, at least in Washington State. And moreover, that the conditions, it's so dry that unless we get a wet fall, there's going to be some real problems with that wheat germinating for next year's crop, at least the winter wheat. And so that there's some real concerns there that this is going to be a multi-year problem. A couple of little tidbits again before I turn it over to Robin. One other parameter that I look at all the time is the vapor pressure deficit, VPD. This shows a portrayal for the Pacific Northwest, the last 30 days. I made it this map last week, and the brown showing where there's a bigger deficit than drier atmosphere, and so not surprising, dry across much of the Pacific Northwest, with southern Idaho that's gotten some recent rain, doing a little bit better. So dry. At the same time, I hear if you actually look in the boundary layer, this is from the INSEP reanalysis, it can, the moisture content, the specific, in other words, absolute humidity, is actually been higher over that same period, while the VPD was higher also. And so this may seem like a contradiction, but it all has to do with the exponential relationship between temperature and the saturation vapor pressure. And so at 80% relative humidity, you as the temperature goes up, the absolute amount of moisture in the air goes up, but also the VPD goes up. And so you can have this kind of conflicting signal. And the VPD is what really counts, is my understanding, with respect to evaporation and transpiration from vegetation. Andy Quixote and Sim Larkin have shown that in general, VPD is going up in the Pacific Northwest, and with that, implications for wildfire risk and so forth. All right. My last little point before just a couple of summary thoughts is about this particular drought, and kind of following up on some work that Karen has done. And that is, there are different flavors of drought in the Pacific Northwest. It's not always, and this is a good example, what happens in winter. Certainly in 1992, it was on the warm side in winter and definitely the dry side. In 2001, a major drought, and here I'm focusing on Washington State, but it applies in general to the Pacific Northwest. It was more a dry winter. Temperatures weren't that unusual. In 2015, it was a really warm winter, and precipitation wasn't as unusual and led to really low snowpack. And then we have this year in which, like I showed in my first slide, you know, the snowpack, at least in parts of the Pacific Northwest, was pretty healthy. And it was spring that was the problem, that was exceedingly warm and dry. And so, again, there's different ways for things to go wrong. All right, this summer, belaboring the obvious, you know, it's going into the record books. And in particular, yeah, some of the temperatures that we've seen just been so extreme, and as part and parcel of that, much of the Pacific Northwest is experiencing exceptional drought. And with that, I appreciate your attention. I'm happy to take some questions, or, you know, I sort of forget whether I'd like to do them all at the end or whether Britt's the boss anyway. So thanks.
Thank you, Nick. As we transition to Robin, do we have any questions for Nick, Megan?
Yeah, one quick question. Nick, on that slide where you mentioned what a difference a year can make, there was a question about whether those two maps are referencing the same normals, and what's the normals that it's referencing.
Yeah, and so I will bring the offending slide up. Yeah, this is from the Westwide Drought Tracker, and yeah, they're both referring to the 1981 to 2010 normals. And so that's a great point, that of course temperatures have you know, were pretty high in the 2010 decade, and so they'll look a little different with the new normals that are being starting to be used in. So thanks for the question.
All right, thank you. That's all the questions right now.
Great. I will hand it over to Robin.
Okay, great. Thank you, Britt, and thank you, Nick. And Nick, you have set the stage, and I'll go into the drought and climate outlook. Good morning. My name is Robin Fox. I am the service hydrologist at the National Weather Service in Spokane. And we are going to go through the presentation. Here's a little overview of what I'm going to be talking about. We'll go into the outlook in the near term, or into the Labor Day weekend. Then we're going to look at the outlook for September, the rest of fall, and then look at areas like the wildfire potential and the drought outlooks, along with the NSO state and the outlooks for that. And I also have some more information to share with some of the drought impacts, especially for Eastern Washington and North Idaho. So for the near-term outlook, now thankfully the extreme heat has come to an end, and some of the northern portions of our region have picked up some well-needed rainfall, especially over this weekend. Some parts of our areas picked up about 1/2 inch to almost 1.5 inches of rainfall, which has been terrific. The upper level ridge that Nick showed us, that high pressure that's been around for a good portion of the summer, well, it's going to be suppressed as we get more little waves of low pressure troughs rolling through the Pacific Northwest. And that's the anomaly that we see in that upper right-hand picture. So we're going to see more little impulses moving through our region. This will bring some light precipitation across portions of Western Washington and the mountains of Northeast Washington, Idaho Panhandle, and into Montana. And as we can see at that chart on the left, which is the days 1 through 7 precipitation forecast. So this will benefit a lot of the areas where we're seeing wildfires right now. So that is good news. Unfortunately, the dry conditions will still continue across parts of the Columbia Basin of Eastern Washington, much of Oregon, and southern Idaho. And then looking at the start of September, which is the anomaly chart, which is in the lower right-hand picture, it still shows the presence of these little troughs moving through the area. So that is good news. That will keep the heat away and bring us a stretch of more seasonal type temperatures for much of the region. In addition, we'll also see maybe some breezy winds kicking up locally in some areas, especially in the Columbia Basin. So if we look at the Climate Prediction Center's 8 to 14 day outlook, which now stretches into the Labor Day weekend, it is showing temperatures will be trending near to slightly cooler than normal, and that'll be mainly across Montana. And for the precipitation chances, they'll be favoring below normal levels for much of the region, but we may be seeing some precipitation across Northeast Washington, the Idaho Panhandle, and parts of Montana as we get more of those little waves moving through the region. Now, if we look at the Climate Prediction Center's 1 month outlook, so for the month of September, it is favoring above normal temperatures across much of the Pacific Northwest and the Western US. For precipitation, it's looking at maybe near seasonal normals for parts of Western Washington and Western Oregon, while the drier conditions are still favored for that interior areas of the West into the Great Plains. Now we look even farther into the future. Here's the 3 month outlook for the fall months from the Climate Prediction Center, which includes September through November. And it is favoring temperatures to be warmer than normal, still across Oregon, southern Idaho, and into southern Montana. While to the north, the skill is lacking, and we could see equal chances of at or below or near normal levels across much of Washington and the Idaho Panhandle into northern Montana. If we look at precipitation, it is favoring above normal precipitation for Western Washington and Northwest Oregon, which is great news, with the below normal areas shifting to the east across the Rockies into the Great Plains. Now, here is a model forecast. This is the North American Multimodal Ensemble, and it is used for seasonal forecasting. And what we can see is it does support the Climate Prediction Center's forecasts. It is showing across much of the Western US and much of the US that temperatures are going to be favoring above normal conditions across much of the area. And for precipitation, on the right, we see some increasing of favorable above normal conditions happening for parts of Western Washington and into British Columbia, along with parts of California as well. So there is that trend continuing of at or above normal temperatures with more of a wetter pattern possibly coming as we move into the fall season. So as Nick pointed out, the Drought Monitor does show drought has expanded across much of the region. And with the lack of spring rainfall, this allowed areas of D3 to D4 across much of the interior sections of Washington, Oregon, and into Idaho. The outlooks for the monthly and the seasonal drought outlooks show similar trends, with some improvements noted for Western Washington and the Northern Cascades, where we're going to be seeing a slight increase in precipitation in the coming months. Unfortunately, we have a lot of brown on the map, and that is showing that drought is likely to persist for much of Eastern Washington, Idaho, Montana, Oregon, much of the Western US. So here we have is the observed water year runoff from the Northwest River Forecast Center. And it is showing areas that are highlighted in green and in blue with above normal runoff that happened with the snowpack that was above normal for the Cascades. And we see as we travel away from the Cascade areas, those numbers dropping off considerably, showing that the runoff has dropped off across much of Oregon and Idaho and into Montana. Now these numbers translate well to the water supply outlook from the Northwest River Forecast Center. We can see areas near the Washington Cascades have fared well with the water supply. Yet the farther you travel both west, south, and east from the Cascades, we see the water supply numbers have decreased rapidly. And we have seen the water supply being adjusted over the last several months to a downward trend as we were seeing less and less precipitation. What we are also seeing is parts of Western Oregon where there's a lot of red right there. They're ranking in the lowest ranking of water supply values that they have seen. We've also seen very low levels down in southern Idaho and even parts of eastern Washington as well. So right now we are in the height of wildfire season, and it has been a busy one. Here is the outlook for the significant wildland fire potential released from the National Interagency Fire Center in Boise, Idaho. And it shows above normal activity is likely to continue for much of the region in the month of September. But good news, as we get into October, things start falling off back to normal across the region. Unfortunately, we're still going to see some elevated levels for parts of Montana into the northern Rockies and parts of California as well. So now we're going to shift gears to ENSO, or the state of the El Nino Southern Oscillation. Currently, we are seeing sea surface temperatures that have been trending near to below average across much of the equatorial Pacific Ocean over the last 4 weeks. Some of the exceptions being in the western and then the far eastern Pacific, which have been trending above normal. Currently, the ENSO state is neutral, but based on these trends, the Climate Prediction Center has issued a La Niña watch for the upcoming fall and winter season. So here are some model outlooks for the ENSO state for the upcoming months. The probabilistic forecast on the left shows an increasing trend for La Niña as seen in those blue bars. As we move into the colder season, so October, November, December, and into the first part of the new year. Yet, we are seeing those gray bars that indicate ENSO neutral state have a strong possibility, especially for this fall and again for this spring. The graph on the right shows the prediction of the ENSO state based on the sea surface temperature anomalies in the Pacific. The majority shows cooler than normal sea surface temperatures for the upcoming fall and winter season, albeit a slight cooling in some of the models. Remember, La Niña is forecast when sea surface temperatures trend below normal by 0.5 degrees Celsius or more. Now, La Niña conditions typically brings slightly cooler and wetter conditions for much of the Pacific Northwest during the winter season, but not all La Niñas are the same. So we shall see what will be happening for our winter season. But now I want to kind of circle back to some of the drought impacts that we have seen. Now, Nick touched on this with the agriculture, and this has impacted a lot of the inland Northwest, especially with dry land agriculture, which has been hit especially hard for the region. So the graph on the left shows how the spring wheat yield has fared over the last couple decades. And you can see how in 2021, it has plummeted much below average. Now this is for, that first graph is for the whole United States. The graph on the right shows the yields for Washington spring wheat. And you can see it as the red line for 2021, which is well below the cluster and practically off the chart. And we are seeing similar trends in this with dryland agriculture for other areas, including the barley crops and the pasture and rangelands, with the 2021 line falling well below the clustering from above. So we have seen many drought impact reports affecting many of the counties in eastern Washington and North Idaho. Another impact we have seen in our region has been wildfires. And as I mentioned, it has been a busy year. The extreme heat waves in both June and July, along with the dryness, allowed the fuels across the region to become tinder dry. And the scattered thunderstorms may not have provided much precipitation this summer, but lightning was plentiful and helped provide the ignitions for many fires. With the map on the left, you can see the number of wildfires across the West and how they are especially high in the interior areas of the Pacific Northwest, where the drought levels have been so high. The smaller map on the right shows a closer view that shows the vast number of wildfires still occurring across Washington, Oregon, Idaho, and western Montana. So to wrap things up, we'll anticipate drier than normal and somewhat seasonal weather through the upcoming Labor Day weekend. So the heat will be subsiding. We'll see some few showers in western Washington and those mountains of northeast Washington, the Idaho Panhandle, and Montana. The September outlook is favoring dry and mild, but then it looks like we're going to be trending to more seasonal conditions through the upcoming fall months. The wildland significant fire potential remains elevated through September, but then dropping to near normal by October. The La Niña watch remains in effect for late fall and winter. And then I also touched on some drought impacts we have seen this summer, including the dryland agriculture and wildfires. And that's what I have for you today. Thank you for listening, and I will be available for any questions.
Great, thank you so much, Robin. Megan, do we have any questions for Robin as I move over to Sonia's presentation?
Yeah, so one question, I think it could go to either Nick or Robin or both. And the question is, are the wildfires that we're having right now, does that impact precipitation? How and to what degree?
I am not really sure if there is a good correlation with the wildfires and precipitation. I know we have been in a drier pattern, which has allowed those fuels to remain dry. And with the added precipitation that we have had, it has suppressed or slowed down a lot of the fires that we have seen. So I don't know if Nick has any other guidance on this or information to share.
Yeah, I echo that sentiment that I don't think that it has, it's not the same as the ice nuclei that are used for cloud seeding and that sort of thing. And so I don't think the smoke has a lot to do with impacting precipitation patterns. It does can have a significant impact on temperatures. And we saw that especially last year in the week after Labor Day, where in west of the Cascades, the thick smoke suppressed temperatures by 10 to 15 degrees or so. But in terms of precipitation, I don't think there's a very prominent effect anyway. Thanks.
All right, thank you. Those are all the questions.
Thank you. Sonia, we'll turn it over to you.
Thanks, Britt, and thanks, Robin, for setting the stage with your description of the wildfire impacts of what we've seen and what we might be seeing coming up. The project that I'm going to talk about today is really focused on that issue, but with a very broad lens, so looking at a variety of different aspects that help us understand what makes people vulnerable to the impacts of wildfire. And the lens that I'm going to present this work in comes from the aspects that I've been most involved in with the FireEarth Project, which has to do with the outreach and the communication of the results coming from the research that the project is focused on. So today what I thought I'd do is first give an overview of the project itself, and a lot of the material that I'll present in this overview come from a fact sheet that Dr. Crystal Colden, who originally put together the proposal for this project, or led the effort of putting finding funding for the FireEarth Project, and so I'd like to acknowledge her work as well. And then I will give a few examples of some of the research that was developed under this project and the science briefs that we have focused on developing to share those results. And so I would like to acknowledge the leads of the different aspects of the different research teams that were involved in this project. And then finally, I'll share some communications insight from our work, mostly on these science briefs. And a lot of this is thanks to Alex Kirkpatrick, who unfortunately wasn't able to join us today. He is a PhD candidate in the Murrow College of Communications at Washington State University and was deeply involved in developing the science briefs that I'll share. And then I'll wrap up very briefly with sort of what is the work that we still have to complete in terms of outreach for this project. So what is the FireEarth Project? The goal of this project is to improve our understanding of how people are vulnerable to wildfire in this region, so that it gives us insights on how to build resilience. And I want you to focus on these key words of future wildfire disasters, because at the end of the day, aren't we all vulnerable to wildfire? Some of the slides that you showed, Robin, make it clear of how widespread fire is in our region. However, the focus of the FireEarth Project is broader, and their definition of vulnerability really looks at not only the direct fire impacts itself, but really looking at what is it that happens before and what is it that happens after fire. And so focusing on what information can help communities become resilient, and those are communities that are able to prepare for wildfires, knowing those wildfires will come, but prepare in a way that minimizes the long-term negative outcomes to the communities in those areas. And so the focus is, and the sort of underlying assumption is that by doing this, by really building resilience, communities have the ability to minimize the likelihood of a wildfire event actually becoming a disaster for that community. And so the FireEarth Project brought together a variety of different teams with different expertise. And so there are different aspects of the project that looked at fire impacts directly on vegetation and on resources, others looking at post-fire hazards, looking at the longer term regrowth of vegetation and the systems that occur across this region. There's a social science component of the project that really delved into community adaptation, as well as an effort to look over the long term and what does climate change mean for fire and future vulnerabilities as well. As I said, I'm going to focus on the aspect of sharing the research results that have been emerging from this work. And so the team used a variety of strategies to share their results, which range from traditional ways to share science results like peer-reviewed publications and conferences. In addition, each of the researchers that are part of this team have completed their own outreach efforts to particular groups. The project itself has 3 demonstration watersheds where much more in-depth research was carried out in, and some of those, a couple of those include Sun Valley and Cedar River. And in those watersheds, different research teams really engaged with communities or with stakeholders in a much more direct way. So Travis Paveglio's team, looking at community adaptation in Idaho, have been working closely with the communities in Sun Valley on these questions. And then Jennifer Adams' team, who is looking at modeling forest regrowth and what that means for future fires, have been working very closely with Seattle Public Utilities because the Cedar River watershed actually is a source of municipal water for a large portion of Seattle. And even though this is a Western Washington watershed, the concerns about fire and fire impacts are really rising in this area, given some of the fires that have been seen recently. And then Jennifer Adams' team has also been working on the Bull Run watershed, though that's not specifically part of the FireEarth project. It is very connected to the Cedar River work, and so I've included it as well. And then overall for the projects, we've taken on a couple of efforts to share the results. One is the science briefs, and then we've also developed a story map to essentially tell the story of these different components. But what I'm going to focus today on are these science briefs. So I'm going to delve into a few examples, but before I do that, I wanted to be clear about what we've been calling science briefs. So these are short 2-page handouts that look to highlight some of the key findings of a particular component of the research that's been carried out in the FireEarth project. And all of these science briefs have a series of components or elements in common. One is this key findings section that really highlight what are the big take-home messages, what are these key results that are arising from the research. The second is this management implications section, which in this particular example, as you can see, is actually a fairly high proportion of the content that's within these briefs because of the audience that these briefs are targeting. Third, I wanted to point out the use of visuals, and this includes both data-based visuals that look to share the data in a way that makes it easy to understand what the conclusions are that are arising from that, as well as visuals just that help tell the story, like images in this case. And then the final component I wanted to point to is that these briefs are designed and meant to be linked to the peer-reviewed publications that they're based on. And when I get to the communications insights, I'll talk a little bit more about that. So to give you some examples of the actual results that we are sharing from the FireEarth project, I'm going to give you 3 examples. This first one comes from the work of Dr. Alistair Smith's team at the University of Idaho. And his team was looking to describe, excuse me, and understand the impacts of fire intensity on trees, and looking at it from the perspective or bringing in components used from other sciences like the pharmaceutical sciences. And so if you think of fire as an agent that has an impact on the physiology of trees, you could have an analogy of a poison or some detrimental element that a person could ingest. And what we're looking to see is, as you increase the dosage of that, what kind of response do you get from the being involved, in this case, the trees? And so some of the key findings they found, they did experimental burns in the lab with seedlings, and they found that as the fire intensity dose, which they measured with this FRED or fire radiative energy density, they found there was an increase in crown scorch and also a decrease in net photosynthesis of those seedlings. When they carried out experiments in the field, the results were different. They did not find a dose response in the mature surviving trees, but they did find a response when they looked at the peak intensities, or the peak fire doses, if you like, rather than the FRED that's more of a cumulative measure of fire. A second example is from the work from Jennifer Adams' team at Washington State University, and they did modeling in the Cedar River watershed, looking at how climate change and how potential broad biomass reduction treatments across the watershed could influence the size of large fires in the future. And they found that these broad biomass reduction levels that they studied had variable effects on large wildfire sizes under historical climates, but pretty consistently led to decreases in large wildfire size under future climates. It was important in this study to note that these reductions in wildfire size were actually fairly modest, while these biomass reduction treatments were pretty intense. However, the key point that this brings up is that even under those characteristics of the study, there was a decrease in wildfire size. And though this may not have immediate management applications for those managing these watersheds, what it does do is it warrants further research into whether reducing biomass could potentially be a tool in the future. So for example, within the results, they found that lower elevation areas actually are more likely to become fuel limited, and therefore where reducing fuels could actually make a difference to fire behavior. And so that future research should really target those areas in terms of understanding whether actual fuel reduction treatments or treatments in particular locations could be effective as a tool. The third example I want to share comes from the social science portion of FireEarth that was led by Dr. Travis Paveglio at the University of Idaho. And one of the studies that his team did was looking at social fragmentation. So they found that social fragmentation, or essentially the lack of cohesion in a community, can actually play a significant role in complicating the implementation of fire response, things like evacuation strategies, as well as that preparation that I mentioned earlier. So from management of public lands or fuel reduction efforts on sort of individuals' properties. This tied with the ongoing trend that they're seeing of increased second home ownership, increases in absentee forest landowners. These trends are considered a primary source of this kind of social fragmentation. And so this research helps emphasize that some of the approaches to improving preparedness in the community don't have to do with what you do on the land around you where the fire will actually burn, but rather that building and developing those community ties that help make a community more cohesive, that can actually have significant impacts on that broader perspective of vulnerability and whether a wildfire is just a wildfire or whether a wildfire is a disaster. So these are just 3 examples of the science briefs that we've developed. And I know those slides were text heavy, and I did that intentionally because I wanted to give you a flavor for how we have articulated these key findings in the science briefs themselves. So it's more focused on what you would get in a written product rather than a presentation. But I would like to share some of the communications insights and acknowledge that this is work that Alex Kirkpatrick has done for us as part of this project. So one that I think is fairly common and well known is to know your target audience, because that informs the language you use and how you design these kinds of products. For us, the audience were land managers, policymakers, and community leaders, and that determined our focus on brief products that were described in lay terms that had a lot of visuals, as well as the dissemination efforts, which I will touch on in our next steps. The second insight is focused on the purpose of these products, because that also informs how you design them. So again, in our case, the purpose was to make our audience aware of this research and why they should care. And this is why we had these key finding sessions and management implication sections, but also why we were linking them to the peer-reviewed publications for the credibility that that provides, but also for the ability to people to look deeper. One insight that I think is really valuable is that our purpose with these science briefs was not to retell the research. Our purpose was to translate the research for our target audience. And because of that, it's a derived product from the peer-reviewed publications, though we still have that connection to the publications for those who actually want the full story of the research. And the review that the authors have done of these science briefs is really focused on accuracy rather than the full picture that we are trying to tell within the science brief. And then finally, sharing information is not enough. And so that's why the science briefs are simply one component of a bigger set of strategies within the FireEarth project that are more focused on engagement. So that includes the engagement in the demonstration watersheds that I mentioned earlier, the story map that I touched on, that has interactive tools that are embedded in it to help users interact with that. And then there's another component of the project, which I didn't touch on, that is focused on gamification as another way of engaging with our audience. So just in the last minute or so that we have here, I wanted to cover sort of what's the work that we still need to complete for the outreach components of this project. We still have a few science briefs that are in production, and so we will finalize those. And then we will package them together and really reach out through vehicles that address and that target our audience, the land managers, policymakers, and local community leaders, to disseminate these briefs. As part of that, we will also share some sort of derived products, such as transforming some of these briefs into blog posts that could reach a broader audience. And then in terms of the process that we went through to develop these briefs and the partnership we've made between my college that is focused much more on the content and the hard science behind this work, with the College of Communications that can really bring those communications insights to our work and help improve how we share these results. And so we're on this and other projects working closely with other folks in the College of Communications in these outreach efforts. And with that, I will open it up for questions if we have. I guess we don't have much time, but I will leave it to Britt to decide. And if you want to see some of the science briefs before we actually make this dissemination push, they are hosted on our website here, and you can see them there. And with that, I would like to thank you all for your attention and hand it back over to Britt.
Great, thank you. Megan, do we have any other questions as we wrap up here?
Sure, just one question. I think this is for Nick or perhaps Robin. There was a question on explaining in simple terms what a heat dome is and how that can cause the extreme temperatures in that June-July time period. This is a question from a middle school science educator looking for a simple general audience explanation for heat domes.
Okay. Robin, if you have one in your hip pocket, I'm all ears, but I could give it a try too if you'd rather. It's your choice.
Why don't you give it a try, Nick?
Yeah, so the heat dome itself refers to that in these conditions where we have the extreme heat waves, there's a thick layer, a column of air with high pressure aloft and warmer than normal temperatures. And when that situation arises, it can reinforce itself. And that those sort of situations, there's typically sinking motion that causes compression and warming of the air. And the idea there is that the atmosphere is three-dimensional and that when we have these extreme heat waves, that the hottest temperatures, hot temperatures aren't restricted to right near the surface, but there's a thick layer of them, and that's reflected in the pressures aloft as well as conditions at the surface. I'm not sure how effective that will be for, again, Sonia just talked about for the middle school audience, but that's what I have off the top of my head.
Thanks, Nick. I guess one question for Sonia. Are there recommendations included for encouraging community building, especially among communities where there's a mix of first-time homeowners and recreation properties or second home ownership?
One of the key elements that comes from all the social science work that's been done under FireEarth is that a lot of these key findings are inherently local, and the importance of really evaluating other communities and other places to see if the same drivers are in place and the same characteristics are in place. And the team is working on sort of a broader set of insights that can really help communities more broadly. And so in the case of the example I showed, that was in two counties in northern Idaho and northeastern Washington. And these are counties where Dr. Pavaglio's team have been working very closely with the communities. And so, yes, those recommendations are being shared directly by the research team within those communities. And they have been very careful to emphasize the importance of, in thinking about scaling that out or scaling that more broadly, to really evaluate and talk to people and really understand whether the same kinds of situations and drivers are occurring in other communities, and therefore whether the results are equally applicable there.
All right, thank you, Sonia. That's all the questions. So Britt can go ahead and wrap up for us.
Great. Thank you guys so much for staying on a few extra minutes for these questions and answers. We will send out a post-webinar email with a link to the recording, which will be on Droughtgov, and we can also send links to some of the resources that Sonia shared so that you can access those. So thank you, everybody, and we will see you in 2 months on October 25th for our next webinar. Have a great day.